Machine learning. Sounds like something out of a science fiction movie, right? It's a term used a lot in technology today, and the high-level concept isn't new at all. We're actually taking advantage of machine learning all the time. But what does machine learning have to do with networking? I'm Phil Gervasi, and this is Network Phil. First, let's take some time to look at what machine learning is in basic terms. A very simple definition is software that can learn from past experience. The experience computers gather is in the form of data, which means that machine learning is actually closely related to data mining and statistics. In 1959, Arthur Samuel, an early leader in computer gaming and artificial intelligence, coined the term machine learning and said, "Machine learning is the field of study that gives computers the ability to learn without being explicitly programmed." Machine learning goes beyond statistics. Machine learning groups and classifies data and then uses a machine learning model to learn new information and make predictions. And that's the key here. Machine learning is about learning new information and making predictions. A machine learning model is the actual mathematical algorithm used to make predictions. And some common examples are the regression model, binary model, and multi-class classification models. Traditionally, we rely on explicit programming and a fixed set of information to produce some sort of output. But machine learning takes known information and uses a machine learning model to deduce new information. And it's in this way that we can say a machine learned. We can break machine learning up into two major categories: supervised learning and unsupervised learning. Supervised learning involves teaching or training a machine with data that's already well labeled. Labels are just explicit tags attached to an input in a dataset. And so the larger the labeled dataset, the better the machine can deduce new information and make an accurate prediction. Unsupervised learning involves training the machine using a dataset that does not have labels. And this is important to networking because the data we get from our networks generally isn't explicitly labeled. With unsupervised learning, computers create structure and meaning out of what are at first arbitrary inputs. The computer doesn't know what each piece of information is exactly. And since they don't have labels, they're very difficult to classify. So a machine uses clustering in this case to identify relationships among the inputs. And by identifying these relationships, that's how a machine can start to build structure in the data, deduce new information, and then make predictions. And there are a few other methods that are worth mentioning, such as reinforcement learning and semi-supervised learning, which is sort of a blend of both supervised and unsupervised learning. So what are some examples of machine learning that we're already familiar with? Think about how Netflix makes suggestions based on previous shows you watched. And think about how Amazon makes purchasing suggestions based on recent things you purchased or even looked at. When you use Netflix or Amazon, you're helping to build a data set that their computers then use to predict what you might want to purchase or watch next. For quite a few years already, the US Post Office has been using systems that scan the outside of envelopes in order to learn patterns in human handwriting so that letters can ultimately get sent to the right destination. Real estate valuation websites like Zillow use a tremendous amount of information to predict the value of a particular property and even figure out how a market is trending. Stock market analysis programs analyze absolutely massive amounts of information to make predictions about market trends and stock prices. And specifically in IT, this is how some email filtering methods work. An email filtering system can learn what normal email looks like and what abnormal email looks like, and then over time, filtering improves as the system has a better idea of how to identify spam messages among all the good email messages. And this is sort of prediction based on probability. But what does all this have to do with networking? One area machine learning has already been introduced to our networks is with WAN optimization. Dynamic routing protocols can't accommodate for very much more than link loss or maybe hard-coded metrics influencing path selection, so machine learning is used to create baselines of network traffic as a data set, which can then be used to make predictions on what paths would be best in any given time, or how and when to apply deduplication, compression, or some other WAN optimization technology. But now expand this to the entire network. There's a ton of information that we can gather about what's going on with our infrastructure. Interface statistics, logged in users, bandwidth consumption during various times of the day, CPU utilization, a ton of information. And with that sort of data set, machine learning can be used as much more than an analytical tool, but also as a means of making predictions of the network and then pushing configuration to the network based on those predictions. So the idea is to apply this in the WAN, the data center, access layer, wireless networks, on our network security programs, disaster recovery plans, and really every part of network service delivery. But is this just shooting for the moon? We have to consider that networking poses some unique challenges to machine learning. First, a lot of network data is ephemeral, or in other words, very short-lived. That's not necessarily a bad thing, but it does mean that network telemetry used in machine learning datasets is very dynamic, constantly changing. Second, network data isn't labeled data, and that makes classification much more difficult. Think about face recognition software. For a program to be able to recognize a face, and in some cases a specific person's face, it would need a data set of information such as images and descriptions of eyes, noses, and lips, and so on. Information that the computer can then use to deduce new information, and in this case, figuring out which one of these images that we show it is a face. Faces may all be different as far as skin tone, the exact shape of a nose or a mouth, but if you think about it, they're all kind of the same too. A human face has 2 eyes, a nose, and a mouth, all in the same general vicinity and with relation to each other. In the same way, networks also have many common traits, like the presence of a router or switches, maybe some certain common configurations, but no two networks are really the same. In networking, we really still love our snowflakes. Each network is its own thing, with its own custom designs, quirks, and one-offs. And this is what makes the application of machine learning to networking very difficult. I've been very surprised with how fast the term machine learning itself went from something known pretty much only in academia to a term adopted by so many vendors today. But regardless of where machine learning is on the hype cycle, it's still a very real thing that already provides us tremendous benefits every single day. So how will machine learning really integrate into networking? Only time will tell, and probably a long time. We've only scratched the surface here, so I encourage you to check out some of the resources I've linked below the video. Make sure you click the follow button in the lower left of this page to get videos and blog posts directly to your inbox, and stay in touch on Twitter. Thanks for watching.